the plan. We are back, and now that the plan finished, let's take a look. Looking here at the logs, we can see that the default security list for VCN1 is going to be changed, and it's adding an ingress rule for port 80 as we defined it there. So 1 to change, 0 to destroy, nothing to add. The plan was saved. Now it's time to apply this plan. Apply from compartment IAC. That's the plan that we created. Let's go with apply. And once apply finishes, we're gonna run the drift report again. Now the apply action finished, we can go back to the stack details and run another drift detection. When you're running the drift detection, you can run against all the resources or selected resources. As we don't have that many resources, we can run with all resources without any impact. We will leave the drift detection running again, and we'll be back when it finishes. The drift detection finished, and as expected, it's in sync. The drift detection is a very powerful tool that helps you make sure that your configuration matches the current state of your infrastructure. This concludes our demo on how to use the drift detection tool and how to fix your infrastructure to match your configuration files. Thanks for watching, and see you in the next video. Hello and welcome. In this module, we will explore Resource Manager templates. In OCI Resource Manager, templates provide standardized configurations that simplify and automate the deployment and management of your cloud resources. Templates allow you to define common infrastructure patterns and reuse them across different environments. This enables you to ensure consistency and efficiency in your deployments. By using templates, you can easily manage complex configurations and streamline your infrastructure management processes. Templates can be Oracle provided or private. Let's see how private templates can be created. In this process, we start with our configuration files, where we define the resources and settings for our infrastructure. Next, we bundle these configurations into a template. This template encapsulates all the configurations and settings from the configuration. The real power of templates lies in their reusability. With a single template, you can create multiple stacks, ensuring consistency and saving time. In our example, we see how a single template can be used to create multiple stacks, stack 1, 2, and 3. This allows for rapid deployment for standardized infrastructure across different environments. Now, let's jump in the console and see how it's done. But before we go to the templates, let me show you a feature that can make your stacks and templates look much more professional and easy to read. Let's go to the navigation menu, Developer Services, Stacks. There's a feature called schema.yaml that allows you to define the dialogues that will be shown to the user that it's creating the stack. Let's create a stack here. Let me find the folder. I have a folder with the schema already. I will import it into. And the difference happens on the next screen for the variables. As you can see here, you have dialogues that show different labels for the variables. If you don't have that, this is how it will look like. So you can see side by side. I added here required configuration. Instead of the OCID of the compartment, I have the name of the compartment, and all of that is done through the schema.yaml that you can drop on the folder. If you take a look at the documentation, you can find a template file that will guide you on how to fill those to fill that file according to your needs. Let's go back here and let's go now see how to create a template. So developer services, private templates, create a private template. I will go to the folder that holds my configuration. Template with schema, it's the folder that I'm looking for. I will upload the files, my template. Let me fix the name here. Description. Template for 2 VCNs. And with create, that it's done. If you go on the template details, you can go and create stack, or if you go on the stacks dialog, you can click on create stack, template, select template. You will have the Oracle provided ones first, quick start, service, architecture based. And if you move to the private tab, you will see my template here. By clicking on the box, I can click select template, and it will give you my working directory, the name of my template. I'm gonna call this stack01. I will click on next. I will fill the parameters here. 10.0.0.0/16. First VCN, I'm gonna call it VCN01. Side block for my second VCN, 10.1.0.0/16, VCN02. Next, create, and my stack is ready to deploy. I can come back here, stack, create a new stack, template, select template again, private, and the same options will be displayed over and over each time the template is called to be used. I can change here the compartment to deploy on another compartment, but I can go here and I fill the parameters here. By creating private templates, you streamline your infrastructure provisioning process, make it more efficient, consistent, and scalable. This concludes our lesson and demo on Resource Manager templates. Thanks for watching and see you in the next video. Hello and welcome. In this module, we will explore Resource Manager private endpoints. Let's say you have a Resource Manager stack that provisions your VCN, one public subnet, and one private subnet. In the public subnet, it will create an instance with a public IP, and assuming it has the proper security list or network security groups rules, a provisioner called remoteexec can connect using SSH and run commands in the provisioned instance. The same is not true for the instance in the private subnet. To allow Resource Manager to connect to the instance, it will require a private endpoint. The private endpoints can be created using the console or as part of the stack. In your configuration, you will need to add the private endpoint resource. It will require that in your configuration a VCN and a subnet are present. Next, you can use this data block that will relate the private instance and the endpoint to be used in the provisioner. Finally, the remoteexec provisioner block, where you will put everything together. The host, coming from the data block, the commands you want to run on the private instance, and the other required options. Please refer to the activity guide for the whole stack code that you can use in your environment. Using Resource Manager private endpoints enhances cloud infrastructure management by providing a secure connection to the private resources. This reduces exposure to potential threats and also helps maintain compliance with stringent data privacy and security requirements, ensuring that sensitive data remains protected within a controlled network environment. Overall, private endpoints offer a secure, efficient, and reliable way to manage private cloud resources.
Oracle Cloud Infrastructure, OCI Database Overview. We will discuss the considerations of running a database on-premise as well as in the cloud. We will also discuss what are the supported type of databases Oracle supports. In an on-premise database, it's the administrator who will need to monitor the utilization of the resources to ensure there are sufficient resources to handle the workloads and to adjust it accordingly to meet the demands. So, considerations for scalability. The administrator will also need to maintain the servers to make sure they're running the databases as well as the application. The administrator will need to make sure not just one, but all the servers are running on a current and not an outdated hardware as well as software, especially if vulnerabilities like an unpatched system will cause a compromise in security. So, considerations for flexibility. The administrator will also need to maintain the costs of running and maintaining the servers. Compromised security or running on an outdated hardware and software can lead to business to lose revenue when there is a breach in security, or more money is required to maintain that hardware. So, considerations for possible increase in costs. Upgrading the entire enterprise system without shutting down the entire system may be a consideration for some of the older servers. Many of the older servers do not have the ability to do upgrades online. So, considerations for availability. There are many benefits for running your database and application in the Oracle Cloud. Instead of the on-premise administrator doing all the things we mentioned, it will be the service provider who will be doing it. It is the service provider who will monitor the utilization of the resources that is needed to run the workloads and will automatically adjust it accordingly to meet the demands, your scalability. It will be the service provider that will maintain the servers running the databases and the application to ensure all security patches are applied and maintained. The Oracle Cloud Administrator will maintain the hardware and the software so they are not outdated without any impact to you. By maintaining the security, hardware, and software aspect to ensure there is no compromise in the security or the performance, this will address the costs for you. You can reduce the cost and increase operational efficiency and reduce the cost of physical storage as well as the infrastructure. With cloud, you pay for the resources you need as your workload demands it, and you don't when it's not required. Upgrading the enterprise system online so that it will have the ability for your business to be continuing and it will always be available to your users. Availability. By having the downtime to be decreased and new tools and as well as applications are now implemented in a much faster rate. Providing access to all your resources in the cloud, be it the server, be it the databases, or even the application. This will address your accessibility to all your users, as they will be able to access it from anywhere. What are the supported database services? When we look at Oracle, Oracle databases are supported for mission-critical online transaction processing application. This will address all your intense analytical processing needs as well. So Oracle Database is one of the database service that the cloud supports. Another is a non-Oracle database, such as MySQL, the HeatWave. It's an open source relational database management system. We also support fully managed database services in a distributed key value database for the developers who wants to focus on the application development. And that would be our NoSQL database. With external database, it allows you to use your cloud-based tools, such as our database management, with your external database. So now you can manage and monitor your Oracle databases that are located outside of the Oracle cloud infrastructure by using external databases. To wrap up, we learned about the considerations of running a database on-premise as well as in the cloud. We also learn what are the supported type of databases that Oracle supports. Oracle Cloud Infrastructure. OCI Database, Oracle Databases. We will introduce the different types of Oracle Database services. Oracle Database System Service on Virtual Machine is a database service offering that enables customers to build, scale, and manage full-feature Oracle databases that runs efficiently on virtual machines. It's available in Oracle Cloud Infrastructure regions around the world. When you launch a virtual machine database system, you select the Oracle Database Edition and version that applies to the database that is created on that virtual machine database system. A single database is created in a virtual machine with the database version you selected. Oracle Real Application Cluster, RAC, allows the customer to run a single database across multiple servers in order to maximize availability and enable horizontal scalability while accessing shared storage. With Oracle Database Service, you manage the database instance, including provisioning, patching, backing up, and disaster recovery. You do this all by using cloud automation tools, such as the Oracle Cloud Infrastructure Console. You may also perform those tasks with command line interface, CLI, or making API calls. Oracle Database Service has two levels of services. You can deploy the Enterprise Edition or the Standard Edition. The database versions are 19C, 21C, and 23AI using virtual machines, which is referred to as database systems. It's run in a secured, isolated environment in our Oracle Cloud infrastructure. What is Exadata Database Service? The Exadata machine is an engineered system for demanding mission-critical OLTP as well as analytic workloads. It is the highest performing and the most available platform for running Oracle databases. In the Oracle Cloud, the Exadata Database Service is 100% compatible with all on-premise Oracle databases and all existing applications. Exadata Database Service enables our existing on-premise Exadata customers to easily embark on a journey to the cloud without any compromise to the database performance and availability levels that they enjoyed on their own premise Exadata deployment. The infrastructure is deployed and managed by Oracle. All supporting infrastructure for the Exadata Database Service is deployed, maintained, and managed by the Oracle operation team, including the data center networking, the private Exadata OREC networks, the physical Exadata database servers, and the storage server, along with the firmware and the Exadata storage server itself. The Exadata Database Service provides a complete service isolation with no over-provisioning of hardware to ensure response time, and throughput is predictable for critical business processes. When you pay the monthly subscription fee for the Exadata database service, the subscription fee is based on the Exadata cloud infrastructure configuration and the number of enabled Oracle CPU, the OCPUs, in the system configuration, where one OCPU is equal to one enabled database server CPU core. The Exadata database service includes easy-to-use web-based wizards to quickly provision an Exadata system and associate the database deployments. Autonomous database. When you provision an autonomous database, you can choose how you want it to be deployed. Autonomous transaction processing, ATP, would be for your online transaction processing needs, and autonomous data warehouse, ADW, for your analytical needs. Both option provides you a fully managed database with both of these type of workloads. Both deployments provides the ability for automation in backup, in patching, in upgrading, as well as in automatic tuning of your database. The ADB serverless, or also known as ADB-S, delegates all operational decisions to Oracle for the highest level of autonomous experience. With ADB serverless, it enables you to quickly provision your own autonomous database and become productive immediately. With ADB dedicated, it gives you fuller or greater control and isolation starting at the Exadata cloud infrastructure level, with customizable maintenance schedules, software update versions, backup retention periods, and so on. It allows you to group and separate out your databases based on your organizational structure and how critical your application workload would be. With the ADB dedicated, it's ideal for customers looking to deliver a self-service database with its capability within your own database cloud environment, running either in the public cloud or at your own data center. With this model, you can have fleet administrators that can customize operational policies to tailor an operational plan for the different parts of your organization. Then the organization can consume via self-service app experience. Oracle database features in our Oracle Database 23 AI. With Oracle Database 23 AI, there are enhancements to the core database functionalities and integrations with AI capabilities. To mention just a few, you have AI vector search. It makes it easy to search documents, images, and relational database based on their own conceptual content rather than specific words or pixels or even data values. With data use case domains, it allows the developers to declare the intended usage of your columns, the data in a column, in a centralized manner. So, for example, you can declare a column to hold a particular data value or items. Think of your email, think of a URL, think of a password, or even a currency value. Now, applications can now use this data use case domains to automatically generate codes or even verified values. With priority transaction, lower priority transaction that block higher priority transaction can be automatically aborted. This feature will then reduce the administrative burden of the DBA while maintaining high transaction level throughputs. With True Cache, it is the ability of having an in-memory, always consistent application transparent, high performance, middle tier level caching. Oracle True Cache improves the application response time while reducing the load on the database servers. With rolling patching, it provides the ability to apply rolling patches and perform maintenance operation locally for your RAC database with one instance or an Oracle RAC one node database environment that is running in the Oracle Grid Infrastructure Cluster. With rolling patches, you now have the ability to provide uninterrupted database availability during maintenance operation, and this will help significantly improve the ability of your databases without expanding them into a multi-node cluster. With your in-database SQL firewall, Oracle SQL Firewall will help protect the database against any unauthorized SQL, including SQL injection attacks. To wrap up, we discussed on the different types of Oracle Database Services, from Oracle Database Service to Exadata Database Service to the Autonomous Database Service. We also introduced a few enhancements that is introduced in Oracle 23 AI. Oracle Cloud Infrastructure, OCI Database, Base Database System Configuration. Shapes for virtual machine database systems. When you configure a database system, you need to select a shape for it. A shape is really a template that determines the number of OCPU, the amount of memory, and other resources that are allocated to your database system. Now, OCPU is the CPU capacity equivalent of one physical core of a processor with hyper-threading enabled. Each OCPU corresponds to two hardware execution threads, known as vCPU. Here's an example of different shapes, their configurations for different processors. The AMD processor is built for multitasking and multi-threaded applications. Here you see an example of one of the shape for AMD. From the naming convention of the shape, you notice that it's flex. Now, there are certain processors that doesn't have flex capability, but for now, for this AMD shape by that name of standard E4 flex, it shows you the number of OCPU, and from that, it will then have a certain amount of memory, network bandwidth, and max operations. For your Intel processors have both fixed and flexible shapes, so the naming convention of the shape is important. With a fixed shape, the number of OCPU and memory are allocated at instance creation time. With a flexible shape, you can change the number of OCPU at creation time, where the fix will be designated by just the name of the shape. With the fix, the number of OCPU is available from 1 to only 24, and the amount of memory is allocated at 15 gigabytes per OCPU. Whereas for the flex shape, you can have assigned anything from 1 to 64 OCPU, and with each OCPU, the memory is allocated 16 gigabytes per OCPU. As you increase the allocation of your OCPU, the available network throughput for your configuration will be displayed in the console. Now, with the Ampere processor is suitable for general purpose workload as well as rapidly growing applications such as data analytics, mobile application, machine learning, as well as in-memory databases and web hosting applications. You can see here is also flex, but you notice the different number of the OCPU and the memory allocation, as well as the bandwidth. When you take a look at your virtual machine database system, it offers various shapes, as we discussed, from anything from 1 to 64, and you can see the range in terms of the availability of memory from that 1 to 64 configuration, the storage, the network, as well as the number of nodes. Your virtual machine database system option provides you for those three processors that we mentioned, the Ampere, the AMD, and the Intel Shape. You have the following. For example, in an Oracle single instance database on a virtual machine, which is a single instance, you now have one node virtual machine database system that consists of one virtual machine. For that one virtual machine, you have the configuration of up to 64 OCPU, 1 terabyte of memory, and up to 80 terabytes of usable block storage volume. Again, this is an example for the AMD. Now, in a two-node rack environment, you may notice the CPU, the OCPU, and the memory is twice as much. And that's because you have two instances. Two-node rack environment requires two virtual machines on separate servers running that Oracle Rack Real Application Cluster environment. But I want to draw your attention. You notice the storage is the same. And that's because, remember, these two instances shares the same storage. And in addition, a friendly reminder, if you are addressing a two-node rack environment, it requires the Oracle Enterprise Edition Extreme Performance license type. Now, after you select the shape for your virtual machine, you can scale it with the OCPU scaling of your two-node rack. Is done in a rolling manner across the two virtual machines. One thing to bear in mind, the memory scale with the number of OCPU and the available I/O performance scales with the amount of storage change. The maximum number of OCPU, memory, and storage for your database depends on the shape you choose. When we address the storage architecture for our virtual machine database system, when you create the virtual machine, there's a choice of storage management. You can either have your logical volume management, your LVM, or your grid infrastructure, your ASM storage management. Now, with your LVM, the storage management is a solution that allows the administrator to combine any number of physical devices or partitions into a single file system or even multiple file system. You can create a logical volume on any file system size and adjust them as you need them. With your grid management, your ASM volume management, the file system for your Oracle database files supports not only the single instance, but also for your real application cluster. With ASM, it allows the disk to be added and removed without downtime, and it automatically rebalances the data across the disk. That's what makes this so powerful and so flexible than just a file system. For a single node virtual machine, you can create either logical volume management or your ASM. Now, in a single node virtual machine, it does provide you fast provisioning option to allow you to create your system, as is mentioned, very quickly. When you do select ASM storage management for your virtual machine, you will select your Oracle grid infrastructure. And you do that when you provision your ASM. It will then use data group as well as RICO, recovery disk groups. By default, when you create your virtual machine, your ASM disk group will be allocated 80% for your data and 20% for your RICO for your recovery groups. You also have the ability of block storage. Now, block storage is a technology that controls the data storage and the storage device. It takes any data, like a file or a database entry, and divides it into blocks of equal sizes. The block storage system then stores the data block underlying physical storage device in a manner that will optimize for fast access and fast retrieval. You can scale the usable block storage volume online to up to 80 terabytes. Block storage provides a triple mirroring, or think of your failover capability. Since the block storage already provides triple mirroring on the data, ASM redundancy is then set to external. The database system clones supports both the LVM, as well as the ASM. To wrap up, we discuss what are the configuration options for virtual machine database system, and we know what are the different system options and what are the different storage options. Oracle Cloud Infrastructure Demo. Launch and connect to base database system. The objective of this demo is to create and connect to a database system. The tasks we will perform would be to create a virtual cloud network, provision a database system, and connect to the database system. Now, we want to make sure a few things are in place before we launch creating this virtual machine database system. We want to make sure we are aware that we will need a public key to be associated with the database system. We also want to make sure we've been granted appropriate identity access management policies to make sure we have access to all the cloud resources. We will need a virtual cloud network, and that is how we will connect to the database because that's where the database will be launched. We'll also make sure that if we need access to storage, for example, to object storage, we will address the gateways. And of course, the object storage itself. This will be storage in the cloud. We can place our backups there. We can place, for example, our patches there. And of course, the compartment. A compartment is really a collection of cloud resources. And the reason we want compartment is because with our policy, it enforces security. It isolates those cloud resources from others and will only provide access for those we grant access to. Let's now create our virtual cloud network. I connect to my Oracle Cloud account, my tenancy, and from the navigation menu, I go to networking, and from networking, I connect to the virtual cloud networks. So I select that. On the virtual cloud networks page, I may create a virtual cloud network. I can take advantage of using the wizard that will automatically do a lot of things for me. So I click and select that. From here, I have an option of creating a virtual cloud network to connect to the internet or one that will connect site to site, for example, a virtual private network. I select the internet connectivity and I click Start VCN Wizard. It's really cool because here you see a diagram that shows exactly what it's going to create for me, my network, the public subnet, and so on. So for now, I wish to provide it a VNC name and confirm that I am creating it in the compartment I'm assigned. I enter the name of my VCN. I confirm the compartment it's going to be in. It asks me the IP address and the version, be it v4 or v6. v6 provides me more bits, but I'll leave it at v4 for the purpose of our demo. I do want it to use the taking advantage of the domain name system or service of the host name in this VCN, so I keep it checked. It asks, do I wish to have particular, again, range of IP address for both my public as well as my private subnet. I leave the defaults and I click Next. Now it asks me to review before it creates it. It tells me my VCN that I will create, as well as the public and the private subnet and the gateways, along with security lists, so I can address security access to my network, as well as route table. I click Create, and you can see how quickly my virtual cloud network is created. And once it updates everything, I can then view to see the virtual cloud network I created. On the virtual cloud networks details page, I see the VCN I created, information about my VCN. Under resources, the details of everything, my public and private subnet, my route tables, my gateways, and other things pertaining to my VCN. Now that we created our VCN, let's provision our database system. From the navigation menu, I go to Oracle Database, and from here, I can select the Oracle Base Database Service. Again, confirming I'm in the compartment I desire, I click Create Database System. It will bring me to a dialog box. So I will fill in the various things I need, and then let's walk through all the fields together. I provide the name of my database system. The next thing it asks me is in which availability domain do I wish for this database system to be created in? Now, a reminder, an availability domain consists of really a set of data centers in my region. In the upper right-hand corner, you may see the region that I am currently in, and here is one of the data centers of the 3 in that region. It defaults to the first one in this case, so I'll let it accept that. The next, it asks me for the shape. Now, a shape is really a template that determines the number of CPU, the amount of memory based on that amount of the number of CPU, and other resources. I may change the shape. And here you see the processor is the AMD. I can also have it to be an Intel or Ampere. But for the one that I select, you can see an example of the name of the shape. That particular name will then determine the amount of resources, the number of CPU, the amount of memory based on that number of CPU, the network throughput, and the operations. So for the number of CPU I desire, it defaults to 4, but I may increase it or decrease it as part of this provisioning. I will make it simple for myself and drop it down to 1. Please be aware, this is just for demo purposes. Do be aware that the number that you need will be based on your workload. Since this is the shape I created or selected, I will then just click Select Shape. It will bring me back to here, and here is my shape along with the number of the CPU I change it to. Next, it asks me for my storage. I can ask for a storage management and determining whether I want a grid infrastructure or a logical volume. Now, even here, you can see for quick deployment, especially for our demo, I may wish for logical volume management. It allows me to change or define the name, or rather the size of my file system. And here I have more flexibility, making it easier. But again, for the purpose of our demo, let's use logical file management. I can ask it to be more balanced or for high performance. From what you will need for your database system, you may make that decision. Again, notice it defaults to high performance because that is what we will do. We will manage and make sure that it will be more appropriate for your workload. The amount of space, you can increase it using the drop down, okay, and the recovery storage. And again, that will be determined by your shape. I will save my changes since I changed it to a logical volume management for the purpose of our demo. Then it asks me for the number of nodes. Now, if I want a single node, or maybe I want multiple nodes. For example, I wish to have this to be a rack environment. Okay? I then may have the capability of selecting my software edition. Now, software edition goes into what is part of that database. Do I want to have more database features? Do I need to be in a rack environment or even in an Exadata environment? It defaults to a particular software edition, but in our case, I will let it default that I can have standard or enterprise edition. So please consult our documentation and make sure that the software edition will meet your business needs. You may notice the total storage is read-only because that's based on the value you selected, and that value is our shape. The next thing is I need an SSH key. I specifically need a public one that will be associated to this database instance, a system that I created, and I need a private key in order to connect to it. So I may download both, and this is a really nice feature because if I forgot to create this pair before provisioning, this will do it for me. So I click, I wish to generate the key, and I wish to download the private key that I will need. Continuing, it asks for my license. If I have a license already for other Oracle systems, I may bring that license, or I may associate a new license to this database system. On which network will this database system be communicating on? That would be the virtual network that we created. You can tell from the dropdown that I may have options. Now, based on this compartment, this would be the one I just created. Now it asks for a subnet. Do I wish for a public subnet or a private subnet? That depends on your network system. I wish to connect to the internet on my machine, so I choose public. I may ask for a security group to control my traffic network. And that's exactly what it is. A security group controls the traffic that allows others to reach your database system and be able to communicate to the database system from the database system. For the purpose of this demo, I will leave it unchecked. Now, I did enter in a host prefix name, and you can always put your mouse on the bubble, as I refer to it, to remind myself what this prefix is for. The prefix is a form of the naming convention. It's the first portion of your database system host name, and it does recommend a certain number of characters, no more than 16. Now, though it doesn't say it, but I will share with you, you do need to provide this, because if not, it will need to create that as part of the naming convention. So please remember to provide a host prefix name. The rest is read-only, because remember, it now takes that form of what it is for your host name as well as for your URL. This will then be how you will connect to your system. I'm not going to provide it a private IP address, and that brings me to the next part of the dialog box, your diagnostic collections. For the purpose of our demo, we can either select it or not select it. So I'll make it a habit to do that because I want to remind myself and my friends, I want to know how well my database is doing. So especially in your production environment, I really encourage you to have the diagnostic collection to be checked. So I'll leave it checked as a default. I click next to take me to the next dialog page. Here it asks me for information about this database I'm creating. Now remember, this is now the database in my database system. I provide the name of my database. I can give it a unique suffix name or just a database unique name if I desire, but I'll forego that for now. And now comes my database image. Think of this as the version of the database you wish for this database system. I may click on Change Database Image, and you may notice these are the various versions of the databases I may have. I may even create my own and have it be associated to this image. The reason I would like to create my own image is maybe there are certain packages, procedures I want as part of this database, and I may wish for that of all the databases I provision. So that being the case, I would consider creating my own custom database images. But for those that's provided by Oracle, here you see the version of your database. You have 19C, but you may also notice we have our latest and greatest, our 23 AI. I select that and I click select because that's what I want my database to be. And then I continue, I may provide it a name for my Hollowell database, or I'll skip that for now, but I do need to manually enter in the name, in this case, or rather the password to log in as user sys, and I need to enter it twice. I leave this check because it asks me, do I wish for that administrative password to be for my TDE wallet? Now, remember, TDE encrypts the data in my Oracle database, and TDE stores its master key in that wallet. So I do wish to use the administrative password for that TDE wallet. Next, we will talk about how to configure for your database backups. Now, notice you will see that Enable Automatic Backup is checked. And that's because we do strongly encourage you to let us automatically perform backups for your database to protect your database. From there, you can also make sure that you have all the prerequisites for backing up your database for that automatic backup. So you can click on this and make sure your system has met all the prerequisites. You can have define your destination of where you wish to have your backups to be placed in this autonomous recovery service, taking advantage of a service, or object storage, which we share together, is an option. You can define your retention policy. How many days of your backup do you wish to retain so that you may recover to that point? You can have real-time protection. And of course, you can define how often or when we need to remove the backups when it's no longer needed, when it meets the criteria of your protection policy, which is this, or you can retain your backups for 72 hours and then delete it. Your first thought would be, why would I only want it for 72 hours? I tend to do that if I am creating a database system, a database, just to test out a feature, to make sure a proof of concept to show something to my VP. But besides that, I may not need to protect it as if it was my production environment, which I'm really very careful of. So considerations and options. When do you wish for the backup to take place? You can have it be done anytime, or you can set it to be a specific time, maybe at off-peak hours for you. And then, of course, when do you want to take your first backup? You can take it immediately so you have a backup of what you just provisioned. Again, if it's just for a proof of concept, you may wish to remove that. But I will make it easier for me. I will just disable the automatic backups. So I don't need to select any of them. But do consider that, again, for your production environment, I strongly encourage that. If you're creating something for testing or proof of concept, you may wish to consider whether you wish to have that feature or not. Now I'm ready to create my database system. You notice it takes it into a status of provisioning. Let's give it a little while for it to provision our database system. As you can see, the status of our database system went from provisioning to now available. Database system is now completed in creation and is available to us. You can always see information on the database system details page. If you go back to just the database system, you can see on the database system page, under my user demo compartment, I have a database system. If you click on the link, it'll bring you to this details page. On the details page, you can see the name of the system, and you can see a lot of features. You can scale up storage. You can change the shape. You want to change the shape of your CPU or storage if you desire. But you can change the storage here. You may clone. You can add another SSH key pair, the public as well as the private key, but you need the public key to be associated with your database system. You can have other administrative actions, such as updating your license type, moving the resource to another compartment, or terminating, which is really removing and deleting. In the database system information tab, that's this, you have a wealth of information. You can always see the status of your database system, the domain that it's in, the OCID, your Oracle Cloud Identifier, which is really nothing more than a series of characters and numbers that uniquely identifies this cloud resource, in this case, my database system. So it's a unique identifier. The shape of this database system, the configuration, the number cord, the compartment. I'm just pointing out various things. The software addition. So this is my high performance. My storage management. I can have logical volume or grid infrastructure. The amount of storage and other configurations. My license type. The version in terms of my patch. And this is always good to see. My system is current and updated. Here you see the network information, so you know which network this database system is on, and that would be the VCN we created. You can also see the subnet, be it a private or a public, the port that it's running on, and you should be very familiar with this port, 1521, that's the port of the listener. And you can also see the host domain name and other security information about the network, which we have none set at this point. So on the left side, you see resources, and under resources, you see database or databases, but we only have one, and that's the name of the database. The unique name that is given to it. If I don't provide one, they will provide one, and it usually takes the name of the database with my region name. The database version, which is 23, which is the latest and greatest, are 23 AI. And you can see more information if you click on the database. And for monitoring purposes and so on, here's your metrics, any backups we created. If you implement DataGuard or addressing the pluggable database, there's my pluggable database, okay, and so on. But I want to go back to my database details. And from my database details, I really want to go into the database, the node. So I'm really back onto the database system details page. And under node, you can see the name of the node. It took the form of my domain name. And here is an IP address. You may notice it's a public IP address, and I also have a private one. But since I am on a public subnet and I'm connecting on a public internet, I would need to use the public IP address. And just in case you're wondering within that availability domain, this is my fault domain. So let's make a note of this public IP address because I will use that to connect to my database. Now that we have our database system created, now that we know it's available, let's connect to our database system. First, in this database system, under resources, if you take a look, you only have one database, but of that one database, there's a single node. And here's the node, the name of the node, which is taking the form of the naming convention. Think of your domain prefix. Here is the public as well as the private IP address. Since I am on a public internet, I will use the public IP address. I am in a Windows environment, so let me bring up PuTTY and use PuTTY to connect to my database system. Now that my PuTTY is up, provided the IP address of my database, and that's this. Here's the IP address. I log in as user OPC because that's one of the user that is created on the operating system or my system, in this case, my database system, in which one in my database system, I have a database that consists of one node. In addition, I provided my credentials. So under SSH for PuTTY, I go to auth for authentication, and under credentials, I provided with browse the name and the location of my private key. Confirming that's where I'll connect to, I will now connect to the database with open. You can see I log in with the user of OPC. It's authenticated with my public key. But you may notice I'm connected as user OPC. I really want to be user Oracle so I can get to my database system, for example, or I should say database rather, for example, using SQL+. So I sudo and I switch user to user Oracle. You may notice now that I am as user Oracle on the machine name and you can see it here. And I am connected as OPC, but I'm switching user so I can perform task as user Oracle. Now, if I desire, I can even type in SQL Plus. And here, it should be something I'm familiar with. I may wish to connect as user sys as sysdba. It prompts me for my password, and I'm in. How cool is that? I'm not only in the database, I'm in the latest and greatest version of Oracle. That is my Oracle Database 23 AI. I'm at the SQL prompt, and now I can take advantage and really play with this database and learn all the cool stuff of 23 AI. This concludes showing how we can connect in our database system. Oracle Cloud Infrastructure, OCI Database, Base Database Managed Features. We will discuss what are the prerequisites for launching a database system, what are the scalability options, what are your backup and recovery options, the cloning features, and the ability to use the Performance Hub to monitor your database. Now, before we launch our virtual machine database system, we need to have the following items in place: a public key, as well as the identity access management policies. You need to have a public key associated with your database. This way, when you need to connect to the database, you will provide the equivalent, the private key, to authenticate yourself. Now, you may either create the key pair before you launch the database system to create, or you may use the wizard, and as part of the wizard, you may select to download the private key that's associated with the public key during the creation. The other thing you would need would be the IAM policies. This is required, as well as the need to make sure the tenancy has the necessary service limits to ensure that you use only what you're allowed to. So having the policies in place ensure the access to your cloud resources, and the tenancy will make sure that you have the necessary service limits. You will need a virtual cloud network, a VMC, that must be created in the region before you try to launch your database system, because this is where the database system needs to perform its connectivity. It is related, or I rather say, it's related network resources. Think of the gateways, the route tables, the security lists, must also be configured as necessary for the database system. At least one subnet is required, regardless if it's a public subnet or a private subnet. For security reason, Oracle does recommend a private subnet. For a 2-node rack virtual machine system, ensure that port 22 is open for both inbound ingress as well as outbound egress on the subnet, and that the security rule you create is stateful. It is by default. Otherwise, the database system might fail to provision successfully. In addition to the virtual cloud network, if you are using storage, think of your object storage, you might need to address gateways. That brings me to storage. One of the options of where to create storage for your database system would be object storage. It's storage in the Oracle Cloud. If you plan to back up your database system to object storage, or you wish to stage your patches in the storage, then you need to address the object storage. In addition, you may need to address Internet Gateway with a public subnet or a service gateway with a private subnet. That will be required. So this is where you put your backups as well as your patches. Now, compartment. Compartment is really a collection of cloud resources. The identity access management policies are used to enforce access control to the objects in the compartment. And we want to ensure that only those resources are available to users that should have access to them. The database system is created in your compartment, in the compartment you're assigned. and you can use the network resources in that compartment. That would be the VCN. Scaling in a virtual machine database system. Depending on the shape that you created the database system, it will then depend on how you scale your system. You can scale your OCPU for a virtual machine database system with flex shape. Remember, that would be the flexible, and it can be done in increments of 1 CPU or OCPU at the time of creation up to 64 OCPU. Scaling the OCPU for your virtual machine with a fixed shape requires that the shape of the system be changed. Now, the VM will be rebooted when the shape of the virtual database system is changed. For the 2-node rack, the shape of the VMs will be changed and rebooted once the VM is completed, and you need to do that in a rolling manner. You do have the ability to increase the block storage at any time without any impact to the virtual machine database system. Storage is scalable for your system and is done separate from the OCPU. So it's not that when you address scaling of your CPU, you must address scaling of your storage. If the virtual machine database system requires more block storage, you can increase the storage anytime without any impact to the system. You can scale the data area of your data disk group or volume independent of the recovery area, and vice versa. The storage side used by the virtual machine database system is determined by the amount of available data storage and recovery area storage that you select. Now, bear in mind, available data storage cannot be decreased, and the recovery storage area purpose is used to store your backup and for the purpose of recovery, and that also cannot be decreased. To scale storage, all you need to do is select the database system. From there, you click the Scale Storage and select the new available data storage size for your database or data or your recovery group, and just click Update. For backup and recovery, the Oracle Cloud Infrastructure manages automatic backups, the preferred method for backing up your Oracle Cloud databases, because you can easily configure backup setting using the console. The automatic backup features supports the original database backing up to another for backup for another database. Your options can be recovery service, so this is a service of the Oracle Cloud, as well as object storage. With your recovery storage, you are backing up your database as part of the service, and this is highly durable, and it is a very fast performance in terms of the backup and providing that availability. When you use the backup recovery service, that is one option, but you also have the object storage. Now, with the object storage, you're basically using the Oracle Cloud Infrastructure object storage for your backup of your virtual cloud database system. You can use the console or the API to enable automatic increment backups, create your full backups on demand, and then view the list managed backups for that database. Now, Oracle recommends using a service gateway with the VCN to enable access to the object storage for your backups. In addition, you may also use the storage of your database, and that would be your local storage. This is where you would store your backup. Think of your recovery area with the features of local storage. All backups are encrypted with the same master key that is used for the TDE wallet. That's your transparent data encryption capability. Automatic backups are deleted when the database is terminated. If automatic backup operation fails, the database service retries the operation during the next backup window. When you need to recover the database, all you need to do is just restore. We know where all your backups are. Cloning. Cloning really creates a copy of your source virtual machine database as it exists at the time of cloning, including the storage configuration, as well as the configuration software and the database volumes. From there, we will then create the clone. There are many reasons to create an identical database from the original database. You may wish to do a proof of concept, so you wish to have a clone to perform your proof of concept. You may wish to do testing, just to name a few. Now, a friendly reminder, when you create that clone, you will need a new pair SSH key. That would be for your public key to associate to the new clone and the private key that you will use to access that clone, or in this case, the database, as well as a new admin password for that clone, because that clone is really a new database. With the Performance Hub, you can monitor your database for defined time periods and download the statistical reports so you can see the performance of your database. You can view real-time as well as historical data. When you do that, Oracle Identity Cloud Service, that's your IAM, will create a policy that will grant your users in order to access the Performance Hub. Now, in order to use the Performance Hub for database running on your database service, on your Exadata Cloud Service, you will need to do the following. And what's also cool is you can even do this with external databases, but you must enable database management. When you enable your database management, you have the following option. You have basic management. This is Performance Hub that will display only the ASH Analytics as well as the SQL Monitoring tab. But if you want full management, which will then display all the tabs of all the subsequent sessions, then you must set that as one of your options for your Performance Hub. To wrap up, we discuss what are the prerequisites for launching a database, what are the things that must be considered before you provision your database, what are some of the features for database management, like scalability options, backup and recovery options, and cloning features, along with using the Performance Hub to monitor your database. Oracle Cloud Infrastructure Demo. Cloning base database system. Now, why would you want to create a clone? Clone gives you a copy of the source database system as it exists at the time of the cloning operation. It includes everything, the source configuration, the software, the database volumes. So it's basically having a copy, as is by its wording, of your original database. There's many reasons for doing this. One of it is you wish to have a copy of your database system so you may perform proof of concept, testing of some features to make sure it's exactly what you wanted to do, and so on. Now, a friendly reminder, when you do this, it does need for you to create a new SSH key pair and an admin password. So for the objective of this demo, we're going to create and connect to a clone database system. So we'll create it and then we'll connect to it. And that'll be our two tasks. We'll first create the clone and then we'll connect to the clone database system. From my cloud login, going to the navigation menu, going to Oracle Database. For my base database service, it'll bring me to my compartment, and here is my database system I created. I'm on the database systems details page. From here, I can click on clone to create a clone of my database system. It'll bring up a dialog box, and you can see information about the source database system, the name of my source database system, the number of nodes, the software edition, in this case, the high performance, the storage management, my logical volume management. It then asks me for the display name, confirming the compartment, addressing the SSH key, the licensing, the networking, and the diagnostic and the database name along with the password. So I confirmed my compartment name. I gave it a little bit more descriptive name for my display name. So I know this is my OU database system 1 clone. I addressed the SSH key. Remember, I need a new one, a public key to associate with this clone. I can ask it to generate a new pair, but I can even upload an existing one. So I click on upload, and from here, it would ask me where, in which location do I desire to get that public key. I selected the location, and you can see here, it brought in the name of the public key from that location. I can ask for a new license, or I can use an existing license by clicking on Bring Your Own License. From my network, I choose the VCN I created for the original, the source database system. I asked for a public subnet since I'm on a public internet. I gave it a unique name for my host name, and I did OUC DB host. I'm still collecting the diagnostics as a habit, but again, for your discretion, being a clone, if you need to collect the diagnostic information, I want to give it a unique name for the database. So again, I attach the CLN for the naming convention. I provide a password for user sys, and that's really all I need for the clone. I click Create Clone Database System, and you can see here it goes into provisioning. So it's just like we did before. It's creating a new database, database system, except it's a clone. So let's give it a few minutes for it to complete the provisioning. The creation of the clone has completed. You can see the status is now available. It has the same look and feel as the original clone, of course, with a different name. Take a look at your DB system information, and you can see the unique information about this database system, the clone, starting with, of course, the OCID, the Oracle Cloud Identifier, and along with some of the other things. But bear in mind, this is a clone, so there are many things that they will have similar. Going down the left panel to resources, you see the name of your database, which we uniquely gave it the CLN. I gave it that name for clone, and information about that database. Of course, it is the same version as the original, but I draw your attention to the node. You may notice it does have a node name, but the IP address to this clone will be a different IP address from the original. So please make a note of this IP address because we're now going to connect to this clone. As I'm in the Windows environment, I'll use PuTTY in order to configure my connection to my database. I launch PuTTY, and in the host or the IP field, I provide the IP address. I still have it on the screen to verify I am connecting to the database of my clone. And here you see the IP address. I connect as the user that is created on the system, which is OPC. And as a reminder, under connection, under SSH, I go to Auth for authentication. I click on the credentials, and on the credentials page, I would go to Browse and locate the location and the file name of my private key. That's what I will use to authenticate me to the connection of the database. I click on Open. Now, as this is the first time that I am connecting to this database on this machine, it'll let me know the key that I provided is not cache. So I want to make sure, or I rather say it wants to make sure that it's who I am. I have no guarantee that the server is the computer I think it is. So I need to tell it I'm okay with it. I can click connect once, or I can just accept for any future connection. I'll accept. It brings me to this screen. As you can see, I connected as user OPC, and I authenticated with the key. And now it brings me to the operating system prompt. I'm logged in as user OPC under the name, in this case, the name of the host machine. This is where my database is running. But I want to connect to the database, not just the machine the database is running on. So let's do that. I connect to user Oracle, or I should say I switch to user Oracle. The operating system command is sudo in order for me to perform administrative tasks. I switch user to the user of Oracle. It brings back the prompt, and as you can see, I am now user Oracle on that machine. Remember, I'm still logged in as OPC, but I switch user. Now I can actually connect to something I'm familiar with, for example, SQL+. At the prompt, it asks me for the username, and I can now connect as, for example, sysdba. It asks for a password, and I am now connected at the SQL prompt. And just like my original database system, I have a database that is on or in this database system for 23AI. So now with this clone of my database, now I can test all the cool features of 23AI and see which of the features that will benefit my business, and I want to become very familiar with those features. This concludes the demo creating the clone, a database system, as well as connecting to that database system. Oracle Cloud Infrastructure, OCI database, maintenance. We would discuss the consideration about upgrading a database from one version to another. We'll talk about changing the shape of a database system and how to address the encryption keys for your database system. Upgrading a database system to a new version, like Oracle Database 23 AI. Database upgrades are not rolling and does require downtime. When you upgrade a database, this is true for even a 2-node rack database environment on virtual machine database system. The process is upgrading a database. It's very similar to upgrading any database, regardless of the version. But there are certain things to bear in mind are the enhancements of the new features. So it is important that the new features or the new release may have changes to the structures of the tables. It may have more columns, less columns, more views. You may have new or change procedures, modify system packages, as well as procedures. What are the new roles and what are the privileges in case anything change, like the new feature in 23AI, the schema level grant. So for example, if you grant select on any table on a schema, for example, to schema HR to user Bob, now Bob can see all the tables in view in the HR schema and only in the HR schema. If a new table is now added to that schema, user Bob will instantly have access to that new table. So a really cool feature, a new feature in 23AI. So it's important to understand what are the changes. Ensure that you run a pre-check list prior to the upgrade process to resolve any issues. There are many options to go from one release to another, from your 19C to 21C to 23AI. One way to upgrade from 19C to 23C AI would be to create a new database system for 23AI. Then move your 19C pluggable database using a refreshable clone, and then taking advantage of the auto upgrade tool to upgrade it. After you're upgrading, you cannot use any of your automatic backups that was taken prior to the upgrade. in order to restore the database at an earlier point in time. So please make sure you address your automatic backups and the backups that you had prior to your upgrade. After you provision a virtual machine database system, you can change the shape at any time to adapt to the changes in performance need. Changing the shape doesn't impact the storage available to the database system. However, if your new shape does have a different processor, it can need to be addressed that you now have different memory and different network bandwidth because of the different shape. So you might need to reapply some of the customization if you're going, for example, from Intel to your AMD. Your shape will change, and that may mean you may have different shapes, different OCPU, different memory, as well as network bandwidth considerations. Migrate your database system from one shape to another can be accomplished by using the changing of a shape. Encryption key helps secure the data, credentials, as well as connection information that is stored on the database. For your virtual machine database system, you can choose to encrypt the database using your own encryption key or let Oracle manage the encryption key for you. Regardless if you are letting Oracle manage your encryption key or you manage the encryption key, it is always a good idea to rotate the key. This way, you're not always assigning it to one key. This will maintain your security compliance. You also should consider rotating the keys if you have any personnel change, as well as if you wish to disable database access from any users. If you switch from an Oracle managed to the customer managed keys, you may do that on existing databases. Remember, note when you are switching from customer managed to keys, a database has the pluggable databases as well as the container databases. It must be open and all table spaces must be in read-write mode in order to do it. Switching from customer managed to Oracle managed is not supported, but you can switch from Oracle managed to customer managed. To wrap up, we discuss what are the considerations of upgrading a database from one version to another. We spoke about the changing of the shape for your database system, as well as the considerations for your encryption keys for your database systems.
Hello everyone. In this and the following lessons, we are going to discuss about one of the flagship database service in OCI database service offering. It is called Oracle Autonomous Database. So let's learn a bit more about this database service and what makes it so different from other database services. When considering the different Oracle database services initially available with OCI database service, they would include VM or bare metal based database systems, or it could be the database in dedicated Exadata infrastructure in public cloud or cloud at customer. They were semi-managed database services, that is, there is a shared responsibility between Oracle and the customer. Many of the actions were triggered by the customer, like patching of the database and the database system, upgrading of the database, manual scaling the configuration as the workload demand rises, manually tuning the application queries running in the database, handling database failure scenarios, handling security, applying security patches, configuring high availability, etc. So these are the actions what you would be performing as a customer on the different database service we discussed. Some of the actions may require downtime, which would impact business, and they also tend to add some management overhead, though not equivalent to an on-premise database deployment and management. But it would be definitely be more productive for you if these overheads are entirely overcome by having a system that self-manages on behalf of you. This is where we introduce you to a fully managed database service called Autonomous Database Service. It eliminates the complex overhead of managing our database while being a highly available, secured, scalable database service with a very high performance capability that makes it an ideal choice for your production database workloads. The core design of Autonomous Database is such that the entire database stack is automated. It encompasses the Oracle Enterprise Database that has evolved with many years of engineering efforts to enrich it with maximum automation into the database functionality. It is built upon the best database infrastructure, that is Oracle Exadata, to further boost your database performance by many folds. Coupled with this is the built-in machine learning capabilities that monitors and automates several key areas, including workload optimization, query performance, security, anomaly detection, and failure handling, with complete automation of the data center operations. And overall, your entire database service is hosted in a highly protected and highly available Oracle Cloud Infrastructure region. Autonomous Database is a fully managed database service. It automates several areas associated with your database deployment. It automates provisioning, configures database based on the type of workload. It can self-tune, automate patching and upgrade without downtime, automatically secures the database from external or internal attacks, and it provides instant elasticity to scale your database on demand. Now let's try to dig a bit more into the several capabilities. Autonomous Database in itself is a self-managing database service. Looking at the provisioning aspect, you can provision an autonomous database in a matter of 2 to 3 minutes. This enables you to achieve your rapid database deployment target timelines for your production workloads. And the database is provisioned in a multi-tenant architecture in a scale-out design comprising of Oracle Real Application Cluster and high availability Exadata infrastructure in Oracle Cloud Infrastructure. Autonomous Database is highly secure platform that protects your database from external threats as well as internal threats. All the necessary security patches are applied online on priority. None of these database admins in OCI can check into your database, as these actions are restricted by Database Vault. And the biggest concern around your data security, this is addressed by mandatory data encryption rule, which encrypts your data whether at rest or in motion. On the various management aspect of the database, it automates all infrastructure and database maintenance activities like applying of storage patches or system patches or upgrades. It can tune your database configuration. It monitors the database and can automate operations for diagnosis and resolution. Autonomous Database also keeps your database safe. It can automatically detect and recover during physical corruptions or infrastructure failures. It removes manual intervention to perform this recovery in the event of a failure or disaster by automating the entire repair process, thus avoiding any chances of human errors and delays. Oracle Autonomous Database is built on the lines of Oracle Maximum Availability Architecture to provide maximum availability and avoid any downtime. It automates backup of your entire database to recover from any unwarranted errors. It also allows you to automate extreme availability of your database service by giving you an option to create standby or backup copies of your primary database, to which you can switch over or fail over in the event of any natural disaster occurring in the OCI region. Scaling of a database system is usually needed to meet the changing workload requirements. This can be dynamic or may be inferred from a capacity planning exercise. And usually scaling operation requires a downtime, but in case of autonomous database, it provides instant elasticity. That is, you can increase your compute capacity when the demand rises and scale down when the demand falls. And this is done instantly without incurring any downtime of your database. At times, it might not be feasible to decide what is the exact compute size to scale your database. Then you can enable autoscale to scale up the compute to 3 times of the provisioned compute to meet the workload demands instantly without you manually scaling up the compute. And when the demand falls, it will automatically scale down the compute. In addition to performing scaling operation on the compute, you can also perform scaling operation on the autonomous database storage which is allocated. Autonomous database can automatically optimize your query performance. It automatically creates indexes, partitions. It automates SQL plan management, automates statistics gathering. It creates resource plans and associates it with services to control concurrency and parallelism so that your application can connect using those predefined database service connection string based on the concurrency and parallelism needs. Autonomous database supports different workload types and has a broader support ecosystem. It is integrated with majority of Oracle Cloud Infrastructure services like data integration, Oracle Analytics Cloud, OCI Object Storage, and developer tools like SQL Developer and Apex, Oracle Developer Cloud Service, and other third-party data integration tools, BI tools, and application in Oracle Cloud Infrastructure or in on-premises. To summarize, Oracle Autonomous Database enables you to relieve you of the several database manageability overhead, providing automation across different aspects, be it provisioning, security, availability, performance, maintenance, etc. so that you can be more productive by focusing on your business and application development. It is protected from downtime. It is safe, secure, delivers high performance. It is designed based on maximum availability architecture to ensure high availability. The machine learning based automation it gives you, and many other such factors that makes it a complete package database service that is ideal for your mission critical database. I hope this briefing on autonomous database service gives you some basic understanding of what an autonomous database is and what makes it so different. Thanks for watching.